Assalamu alaikum friends, you are watching Center Engineering Services and I am your host Kamal Hassan Iqbal. Friends, today we are going to discuss about the analog input scaling, that how we scale the input if analog input come in PLC in 1200, 1500 or 300, 400, and then we will discuss about the difference between the blocks used 1200, 1500 versus 300, 400. So all these things today we will cover in this video, and if you have any query about this, any question about this video, you can comment on this video or you can WhatsApp me. That number already mentioned in our description. So today we will go to discuss about the addressing concept. For the addressing point of view, if you know the addressing, I already make one complete video on this also before, you can see in our channel or our Facebook page, but little bit I will discuss here again. That first we are using smallest addressing is the bit I 0.0. you see mostly we use I 0.0, 0.1, 0.2 or 1.1, 1.0 like this. That we said that is a bit. Okay, if you are discussing about the bit, that these are the bit. So 8-bit combination of 8-bit we can say that is a byte. So I 0.0 to I 0.7 is actually a 1 byte. So if the combination of 2 byte, this combination of 2 byte, you can say that is a 1 word. These are things already we will discuss in video, so again I am only revising this, that 2 byte equal to 1 word, and that this word you can see I give address IW0, and but the second one is IW2, because if you can use IW1 it can overlap for this byte, so that's why we miss one IW0, then IW2, then IW4, like this. You can do the addressing when you are doing in PLC. The two words make one double word. That is actually word is a 16-bit, but the double word is actually the 32-bit. Combination of 32-bit is double word. So that is addressing we will do in our analog signal. So analog signal standard in PLC for the current we can say that is 4 milliamp to 20 milliamp. If you are working in the field, you know the transmitters or the walls mostly feedback, or you can see, if you can check the positioner transmitter, that is given us 4 milliamp to 20 milliamp. Or if you can discuss in voltage, that is voltage also from 10 volt to minus 10 volt. So that is a actually standard make for PLC. That is an analog standard already in all over the world. The same standard is using. Sometimes they use 0 milliamp to 20 milliamp, but that is not a standard. They change little bit, but as per standard that is a 4 milliamp to 20 milliamp, and voltage is plus 10 volt to minus 10 volt. So analog signal is taking 16-bit actually in PLC, that we can say, that is, if you can say in value, that is from 0 to 32767, because normally in our analog we will use the unsigned bit only, mean it is count from 0 to 32767. If you don't know about unsigned or signed, you can see my video already have available on this, what is the meaning of signed and what is the meaning of unsigned value. So here in analog signal using the unsigned value means 0 to 32767. So here one table we will discuss the measuring range that we are using here. Actually the rated range, here we need to check the rated range. Rated range is from 0 mean decimal mean 4 milliamp is given, and the 27648 mean 20 milliamp. About this table you can search or you can work on this. That is a already predefined table that already working a long calculation. After that they make this if you are using 32767, it's mean this overflow, and if 32511, it's mean the over range. And the same like this, if you go to negative side, is under range and underflow. So you can remember this way, our range is from 0 to 27648. So this 0 to 27648, we can call it the raw value. The raw value mean that actually this raw value mean that coming from the analog signal input that we receive, input we can say analog input in PLC is coming from the field is 0 to 27648 value is the raw value. We not can say that is directly shown the SCADA or your HMI that panel operator can operate according to this value. That is not possible. So that's why we can say that is the raw value. So this raw value, when we convert into engineering value, is called the scaling actually, that we are doing today. So what is the engineering value? Actual engineering value is that value that you can see on panels mostly if you are in working field, or you can visit your control panel. On control panel, temperature is showing in degree, like pressure is showing in bar, and level is showing in feet, or you can say percentage, or flow is showing in liter per minute, or you can say that is a square root value like this. That is actually the engineering value that is showing on your HMI or SCADA, and accordingly your panel operator will operate the system. So today we are going to convert this raw value to engineering value, and that is called the scaling. So for this scaling, we are using this linear equation, actually y equal to mx plus c. And how is this doing this mx plus c? If you can see in Siemens S7 1200 and 1500 PLC, scaling can be done with, we are using two blocks actually. One is the norm x and second is a scale x. Norm x can slope m, and we can say normalize the value, and then scale x equal to y, mean it will give converted value to return back to our engineering value. And for S7 300 400 PLC, we use only scale box. Scale box done the complete things that we are required for the scaling. Okay, now we will go and see in our PLC. We will configure a device. In PLC we will configure device, and we will see how this S7 1500 or 1200 work. Add a new device. For adding new device, we will go and use any you can use any CPU here, because we are not doing the physical hardware, we are only doing here simulation. So we will use any of the CPU. Open this. So accordingly we will do the scaling, and then we will see the scaling blocks used in 300 400 also, because we are discussing 1200 1500, or we can say to 300 400, because 300 400 normally ladder diagram blocks are same, and for the 1200 1500 also the same. So these are the two standards, 1200 1500 or 300 400. So now we are going first add that 1500, and if you want to 1200, you can also use 1200, is the same configuration. Okay, that is come. So we add one value or DI card. I will open the main block where we are doing the ladder logic. So for this one you need to go in conversion. Here it is available norm x and scale x. we will put here norm x and scale x. Okay, I will use here one bit for 0. If you want to use, you can use it. If otherwise, no need to use this. No problem. It will not affect. Minimum value, already we discussed 0 and 27648. That is, we already discussed in our last same lecture. Here we select the integer, here we select the real, and here you can say any, I will use any memory bit, because memory word, because here we need to use the analog input. Here we have not analog input, we only exposing, so I will use one word here. Here is converting from integer to real, so it's converting to double word. I will use it one double word. Then here you can say it's real to real. So our range is 0 to 15. Why I say 0 to 15? Because we are going to do this example hour. That monitoring the analog input current, that is from voltage, 0 to 15 volt, using PLC and TI portal scaling. We will do scaling, check the analog input addressing, that we already done addressing this MW10. Second one is use norm and x function to input physical unit used to convert digital from 0 to 27648. Okay, we are going to do this. So we already done this range also, beside addressing also we done. So now we are going to convert it into, here we use this, that norm x output we use here MD14 as the input, and the output we will say anything MD18 suppose. Okay, that is a simple scaling. You can do the scaling. Okay, that is done here. So I will go and do the simulation. When you are doing it in field, so you, in place of MW10 you can use your analog input data coming from the field, that may be your temperature transmitter or your pressure or flow or anything that you are using physically. So you can use MW10 in replacement of that. So here we don't have any using any real analog, so we are using MW10, and we will move accordingly and see the output is changed and what value will come. So that is actually the scaling. Actually this simulator for the 1200 1500 is a heavy software, it will take time. So then we are doing the extendable download to device, then just searching the device. Okay, that's us. So I will load it. For the simulation also video available. If you have any question you can ask me about this compiling, loading, unloading, overloading, downloading, all these things. Okay, this simulation come. can see here, if I try to put here value, if possible I give 27648. Not possible, that is not doing. Okay, I will open here. MW10 decimal. So I'll give here 3276. 276. Here it is coming. Sorry, actually I need to add one bit also. I 0.0. to make it one is true, then this our block is actually on. So you see here I'm given 33. Let's give us, if I will give here maximum value 27648, it will give maximum. So now I try to change from here. If I give here 1424, almost 50%, so to give 25. So that is a scaling, that converting our analog value 0 to 27648 to 0 to 50 degree volt. That here we are using volt. In our example we already say that is our 0 to 50 volt is converting from on this S7 1200 1500. So we are doing this. Okay, that is complete. So now we will add a new device, S7300. Any S7300 you can use. We will add here. Actually this 300 400 is a very simple, so you can easily convert it, scale it. So no need to add non-maximum, you need to add the scale block and you can do the conversion. So if you don't have any conversion available, you also need to calculate it. So for regarding this calculation also I make one video how to you can convert it and how you calculate it. So you can calculate it is very easily. Here I will go and use the scaling. In scaling you can say input. Our input may be any MW10, suppose that we already using before, and I will limit. High limit is our 50 that I give before that. Low limit is 0. Bipolar mean M0.0. Actually bipolar is, if a bipolar is 0, here bipolar value is 0, mean that converting our value is from 0 to 27648, mean unsigned value. If I give here 1 in bipolar, it will convert it into from signed value, from minus 27648 to plus 27648. So here for output I will give MW I will make only simple. Okay. You can monitor here through monitor value. So I will give here. You can see when we will change our output is also change. I will give maximum value, that our range that we already calculated before. If I change here, like it will less than 50% will change accordingly. So that is a scaling. Today our lecture is on this scaling, how to scale and how to make the this converted analog input into our engineering value. So thank you so much for watching this video, and please subscribe our channel.